Hi everyone, and welcome to today's Red Hat webinar. Before we get started with today's presentation, there are a few items to quickly mention. You should see a taskbar at the bottom of the screen. Each icon is assigned to a particular element of today's webinar. If you're not sure what the icon does, hover over the icon with your mouse and a box will appear to tell you the function. Also, next to the slides window, you should see a blank Ask a Question box that allows you to type a question. After you type the question, click Submit to send it to our presenters. Feel free to submit your questions throughout the webinar, and our presenters will address as many as possible following the presentation. You can submit any technical questions related to the webinar platform here. Please close down other browser windows or applications that might be splitting your bandwidth, including VPNs, as these might interfere with the audio or video stream. If you experience any connectivity issues, please refresh your browser. Today's session is being recorded, and all registrants will receive an email within 1 to 2 days of the event with a link to view this presentation on demand. Now I'm going to hand it over to today's first speaker so we can get started with the presentation.
Hello and welcome to Automating CICD Pipelines and Policing Applications. We're going to be going through introductions, the purpose for this talk, the framework and architecture of how to implement security within your CICD pipeline, as well as a demo showing that, and how to apply this to your organization wherever you are on your CICD journey. And we'll leave about 15 minutes for questions at the end. So my name is Emily Brand, and I'm a Territory Services Manager in Financial Services within Red Hat Consulting. I specialize in middleware along with middleware migrations and am the Integration Community of Practice Manager within Red Hat.
Hi, I'm Justin Goldsmith. I'm a Senior Consultant within Red Hat Consulting, and I'm also the Open Source Enablement Pathway Community of Practice Manager.
Hi, my name is Nick Balkasoon. I also work in Red Hat Consulting. I'm a core member of the Open Source Enablement Pathway Community of Practice, and I've specialized in CICD security.
There is a common push and pull of security versus innovation, but what if it wasn't a tug of war and instead a process that happens hand in hand? We will be covering how to use tooling that is common in the IT industry to manage security at the application layer without causing strenuous time-consuming reporting and security scans of your entire environment or long sessions of security reviews of new and developing applications. Let's say you're in charge of your infrastructure or application architects and developers innovating every day to push better features. How can you be confident you are not introducing new vulnerabilities by trying to get code faster out the door while leveraging the open source community? How do you encourage application developers to use your process versus creating shadow IT to meet the business needs? You may already have a white list of libraries your developers can use, but how do you check that today? Do you have to personally view the application architecture diagram or do intensive panels to approve production pushes? Every day that you postpone a production push is a day of lost value, and every lost day gradually makes the application irrelevant. So why should you care about open source libraries application developers use? What happens if multiple application teams use a Java library of multiple versions that is then found to have a security breach? Right now, what most organizations do is that they actually go through a costly scan of their environment to look for the vulnerability, but they have no easy way of scanning their whole environment for this breach in a timely manner. It usually requires getting a security scanning software, or if they already have one in-house, to then scan out the entire environment, do the full auditing, and then look up how to remediate each individual application without having an easy way of actually fixing the security vulnerability. How do you catch these breaches over time? You can scan the entirety of your environment monthly, quarterly, or yearly to hit auditing standards, as is what's common in most industries, but does that really mean your infrastructure is safe and secure? What if you scan during each push to every environment, including your development environment builds? Developing a CICD pipeline to automate testing has already become an industry standard. Let's take it one step further and build in security checks for the open source libraries your application developers or you yourself as an application developer can use. Let's take the risk from open source libraries outside of the ones that can be supported by Red Hat and other open source companies. So I'm just going to take a second and let you read this quote from Jeff Bezos. Most security teams are known to application developers as gatekeepers, but gatekeepers add time to delivery. What we're going to show you in the demo of this webinar is how to build security within your pipeline using OpenShift and a security tooling framework to ensure you are not exposed to vulnerabilities and to allow your teams to quickly remediate when vulnerabilities are found. Do not let security be the bane of your developers' existence, and do not allow your developers to get around security. Security is an integral part of every organization's IT infrastructure. Let's have security go hand in hand with application development to ensure a secure IT infrastructure.
So the question I want to ask is, why is this being considered now? What's changed? What's different than in the past? So to start asking that question, let's look at the different development methodologies that have occurred since we started building web applications in the mid-90s and other applications decades before that. What did we used to do? And what we used to do was waterfall. We had discrete phases. Everything was unique. First, we discovered what we were trying to do. After we did that, we designed it. We built out specifications. Then we did the development. We wrote our code like we do today. And then after that was done, we tested. If there was any issues in testing, we went back to development. It was discrete cycles. It wasn't iterative at all. So when did security come into play here? Of course it came into play. Security was still important. It always has been important, but it came into play after the fact. We had big bang releases. We didn't deploy to production every single day. We didn't deploy to production every single week. We deployed to production once a year, once a month, once a quarter. It was in large chunks. So then we went to Agile. Things changed. Everything started becoming more iterative. We still had those same discover, design, develop, test phases. They just happened within a 2-week sprint, a month sprint. And at the end of that short period of time, we had what we called the potentially shippable increment. Right? That doesn't mean it went to production then. It just means that it was theoretically ready to go to production. We still might have deployed, once that same phase, once a quarter, once a year, once every 6 months. It wasn't a standard. We didn't deploy after every single one of those sprints. Sometimes some people may have, but not always. It wasn't common. So security still happened typically on the right side of that process at the end. Right before we went to production, we did some kind of scan. We looked at what components our application were made of, and we kind of figured out what was wrong, and if we need to fix anything, just went on the backlog for another one of those iterative sprints before our potentially shippable increment was actually ready for production. So let's talk about this quote that I have on the screen. DevOps extended the value of Agile so that we went from just continuous integration to continuous integration and continuous deployment. So, when we were doing Agile, people still did CI. Continuous integration was hugely common. We had our CI builds. We ran our builds. We ran our tests. What was missing here was we didn't typically deploy in an automated fashion still. It was better, better than waterfall, but we're still missing that piece of deployment being baked into these pipelines. So that's kind of what changed. We went from continuous integration where these security scans happened after the fact, and because they were after the fact, they could be done manually. These weren't, 10 times a day going to production. These were going to production once a quarter. So these manual efforts, while still time-consuming, wasn't necessarily the constraint on your system, and because it wasn't a constraint, people didn't always care. So now we're going to talk about OpenShift and how our Red Hat's product can play into this. So before we do that, let's talk about like the infrastructure as a service versus platform as a service. So infrastructure as a service is basically you're providing a push-button means infrastructure as a service. We're just talking about your base operating system here. You're not talking about having JBoss EAP to run Java applications. You're not talking about having Node installed to run JavaScript applications. You're talking about an easier way to get your operating system, get your infrastructure that you're going to be deploying on. Platform as a service takes that to the next level. Now all of a sudden we're talking about developers having to care about just writing their source code, and the platform's taken care of. Pushes to getting code to production, or even just the first step of provisioning an environment becomes way easier because we already have the generic boilerplate stuff for Java applications or JavaScript applications handled. All we have to deal with as developers now is working on our code and making sure that works. Red Hat decided to do that with containers, more specifically Docker. So what does that mean? So containers are basically an image that describes and contains both your operating system and your application kit. So it's a single deployable unit that is both your platform and your application kit. And how does that help us? What that means is it's more consistency across regions, because now you have the same exact infrastructure in dev, QA, production, because you're deploying that same unit that is everything. So why does security scanning matter more now? And PaaS and containers, play a big part of that. A, we're deploying to production 10 times a day. That manual step after the fact, we don't have time to do that manual anymore. That becomes a constraint. That slows down our deployments, so we can't afford that anymore. And B, now that our infrastructure, our platform, and our applications are intrinsically tied, they are a single unit, a single deployable, we no longer have security of the platform separate than security of the application. They are a single thing. So we can change the platform just as easily as we can change the application code. And that's different than usual. So, there was always a heavy focus on infrastructure and platform security. That's handled after the fact, and that was also fairly static. That doesn't change very often. But now that the infrastructure and platform are part of the same, again, deployable unit, and that can change more frequently, it makes scanning that and having a view of your vulnerabilities ahead of time way more important, because, again, we can't afford that manual effort anymore. So now I'm going to talk about this graph. This graph basically shows the 10 most exploited CVEs in 2015. 97% of all exploits that were known in 2015 were because of these 10 CVEs. And if you look at them, let's look at the dates there. 2002, 1999, 2001. These are over a decade old. We were talking about that we cared about security before. I mean, this kind of makes it seem like we didn't. So why is that the case? Why is this happening? And I come from a development background, and the answer to that is I didn't know this existed before I started working in this space. I cared about feature work, and when I thought about security, I thought about authorization, authentication. I didn't think about vulnerabilities that were just part of the components that I'm using in my application. It was just something I didn't know about. And that's kind of why this is incredibly important now and why we're focusing on this being upfront in a CI/CD pipeline. And that's because this should be in your face. You should know about this every single time you do a build. You should know that when your components have a vulnerability, it may mean your application is vulnerable. And again, this is hard to track because now we're talking about feature work that business users care about separately than a technical story that they don't care about and there's no way to demo, but they don't want their data being stolen because you included a vulnerability. That's not okay. So this is just as important, if not more important than the feature work, because this is, again, you can't have your data being stolen. You can't have your applications being brought down because you have a vulnerability there. This has to be upfront and center. So what does this mean in terms of Red Hat? Red Hat has one of the best mean times to recovery in the industry. What that means is when we find a CVE or a vulnerability in one of our products, we fix it fast, faster than almost anybody else. But it doesn't mean that these changes are automatically getting put in production. You have to modify your application, modify your platform to take advantage of the new code, the new platforms that we push that are no longer vulnerable to these discovered vulnerabilities. So again, just because you're using something from Red Hat doesn't mean it's clean. You have to use something that's up to date from us, and you have to follow our errata, look at what vulnerabilities we say our components have so that your applications are not vulnerable.
All right, thank you, Justin. Thank you, Emily. Emily and Justin stressed the importance of security, being aware of security more often in your builds. So instead of what in the past used to be monthly, quarterly, you do these security reviews of your application. Now we're talking about we need to do this with every single build. So how do we actually do that? What does that look like? And so we proposed this is a potential architecture that you could use within your organization to achieve this. So on the left here we have our developers, and these are really smart people pushing awesome code every single day, a lot of features. Very, very, very quickly pushing code, and they're pushing this into a source code repository. For example, Git. This is being pushed into a CICD tool, perhaps Jenkins. This is being built, and so this is probably a pipeline that you're familiar with in your organization. Now, the step that we're stressing that Justin and Emily have brought up is how the security scanning and the security management of your application needs to be front and center. So it needs to be part of that build. So as you can see here, from your CI/CD tool, you're pushing to a security scanning tool, some security scanning software. Now this tool has a vulnerability database of all known vulnerabilities, and it's checking on every single build. Are any of the components that you're including in your application vulnerable? And now on every single build, you're also generating a security report, which your developers or people in DevOps or someone from your architecture team, they can look at that and they can be aware of every single vulnerability that their developers are introducing into their code base. And again, so all of this, bringing this back to OpenShift, all of this can be actually containerized, and this environment, this CI/CD pipeline can easily be spun up in an OpenShift environment. So talking about these security scanning tools, there are a lot of tools out there, and security scanning has been around for a while, but now we're talking about introducing it more upfront in your application. And so in the demo that we're about to get into, we're using the Sonatype Nexus Lifecycle tool, and this is a tool that we are familiar with from some of our work, but there's a lot of tools out there, and we recommend you choosing a tool that works for your organization. All right, so we're about to get into our demo, and real quick before we jump in the demo, I want to quickly mention that this is a recorded demo. As we all know, live demos can be difficult and lead to issues, so we've recorded this demo. However, we will be speaking live over the demo, so just be aware of any interesting transitions that might come as a result of that.
And at this time, please full screen the window in the top right button. The little window button will full screen it.
Great. So again, my name is Nick. I'll be leading the demo today. We're going to do a little bit of role playing today. We're going to pretend that we are part of an engineering organization and that we've built this web application called the Red Hat Cool Stuff Store. So essentially all this is, it's an online marketplace. You can go in here, you can purchase some products, add them to your cart. It's actually a pretty cool application running on JBoss EAP behind the scenes using our BRMS tool. And so it's a pretty simple application. And so our engineering team has, oh, okay, this is interesting. So our application has gone down. I'm not really sure what happened here.
So I noticed that, the application had a vulnerability there, so I decided to exploit it. So I took it down.
Okay, Justin. So Justin has just admitted to us that he has taken advantage of a vulnerability within our application. That is not good. So yeah, let's look at some ways in which we could have practiced better security management in order to have prevented vulnerable code from reaching production. So Justin and Emily have talked about the what and the why of why security needs to be a part of our build, but I'm going to talk about the how. So in our demo today, we're going to be looking at how you can take a security-first approach in your organization, and I'll show you some steps and tools that you can take advantage of in order to maintain a strict security policy, but at the same time continuing to enable your developers to innovate and produce at the speeds that are expected. So in this pipeline on the left side, you see we have this cool store build, and that's where developers are pushing their code every single day, very fast release cycles. And this pipeline extends, we build the code and it continues, and eventually on the right side, we're deploying the code and we're having some user acceptance testing. But what I really want to point your attention to is this second step here. And you can see here that this step is orange, which Jenkins, and again, this is an instance of Jenkins that we've containerized and actually hosting in OpenShift, sort of similar to that architecture diagram I showed before. But so this security scanning step we have included as the second step in our build pipeline. So every single time a developer is building and pushing their code, security scanning is a very key part of that build. And it's going to warn them every single time a vulnerability comes up. So we see we have vulnerability here. So the next thing we're going to want to do is dive into this build and take a look at some of those details to see if we can have some more information about what this vulnerability is. So this is just more details on the build, but what I want to take a look at here is the application composition report, which Sonatype has generated for us. So now we're using the Sonatype Nexus Lifecycle IQ server, as I mentioned before, and the two main things that we're going to be looking at, the two main features of this tool that we're going to look at are one, that it can create a bill of materials for you. It can give you a high-level overview of the components that exist within your application. And the second thing that it's going to do for you is it's going to show you, it's going to scan those components for you and show you if you have any vulnerabilities that are appearing in your application. So this is right here just a high-level overview. On this policy page here, we get a little bit more granular about the details of our application. So I think our application said it had 81 components. Here we can look at every single one. So from a supply chain standpoint, you'll know every component that's being included in your application on every single build. So this is a very powerful view to take a look at here. And it gives you information about every single one of these components. So you're empowered here with information about your application, but also information about those components. And now on this page, we're diving down into the security issues that we've identified within our application. So we can see here we have Commons Collections has a 9 rating vulnerability. So that's not good. We also have these 4 or 5 other vulnerabilities. So let's dive into this Commons Collections vulnerability and see if we can learn a little bit about it. So feel free to take a look at this description that this tool gives you. But real quick, I just want to give you a brief overview of what Commons Collections is. It's Apache Commons Collections. It's a very popular Java library It's supposed to improve upon the JDK and essentially make developing in Java a better experience and more efficient. A vulnerability came out with it in late 2015, and this is such a popular library that it affected countless applications. And it just sort of came out, and a lot of people weren't aware of it. And Justin, since you've already proven yourself to be a master hacker, could you explain how you exploited this vulnerability?
Sure. So first off, let me say that the Cool Stuff store was not vulnerable to begin with. I modified it a little bit for the sake of the demo so that I could exploit it. So basically what Commons Collection vulnerability is it basically does something called untrusted deserialization. What that means is you send a serialized Java object, so basically a representative Java object that's not actually in Java, and it deserializes it and turns it back into a Java object. When you do that, what this vulnerability does, it allows you, if you serialize something in a certain way, to run a command against your operating system. So all I did was serialize it, and it ran that command, which just turned off the application.
Yeah, thanks for that. So now we can take a look at what this, we can dive into the details of Commons Collections and learn some information about how we could maybe fix it. So this is a really cool view about the history of Commons Collections by version. So we see here, wherever there's this red arrow in this view here, that means that that version has a vulnerability. So 3.2.1, that's what we were using, that has a vulnerability. But now we can see, okay, 3.2.2 doesn't have a vulnerability. So that's really useful information to know. And now, if I'm in charge of our application security, I can start making recommendations about what version to use if we're trying to remediate this vulnerability. So now we can think, okay, based on our application's architecture, what could we do? All we need to do is upgrade from 3.2.1 to 3.2.2. Real quick, I want to jump into how we manage policies within this Sonotype tool. And the reason I want to come here is we've talked a lot in this presentation about how we need to manage security, but at the same time, we don't want to stifle developer productivity. And so when you're making decisions on how to manage security, there's different things you can do. And here, if you notice below, we choose to warn on a build. And so what this means is if we're building our application and we notice that there's some sort of security vulnerability, we're not going to just fail the build and tell our developers that their build failed. We're going to warn them, and so that allows developers to continue to develop at the same rate without constantly getting these red builds, which could potentially stifle their productivity. Now another recommendation might be, okay, maybe on release we want to fail. We don't want to push vulnerable components, vulnerable code. We don't want to push that out there. So maybe on release fail, but maybe on build just warn. And so again, you're constantly doing this balancing act between, we want to make sure our developers are aware of security, but we never want to very heavily impede on their productivity. And so you have to make trade-offs like this. And so warning on a build, these tools provide the options for you to customize this for your organization. So whatever fits your organization tends to be the best. So now we're actually going to try to fix this vulnerability. We're taking a look at our project here. We're going to go into the POM. So essentially all the dependencies, all the components that our Cool Store application needs to run. We're going to go in here. We're going to search. We should find Commons Collections in here. So we're going to search for that. And okay, so yeah, we see here we have this dependency Commons Collections, and we see 3.2.1. And as we identified before by the Sonotype tool, this is the vulnerable version. So we also saw that version 3.2.2 is not vulnerable. So all we have to do here is upgrade from 3.2.1 to 3.2.2. And I'm hoping Justin doesn't hack my application again. I'm hoping that works. So we're gonna commit this code. We're going to say, we put in a commit message, we upgraded our Commons Collections. We're going to push this. We're pushing this back into our source code repository. And so that's going to automatically produce a build. So that's going to go directly into our CICD pipeline. So if we take a look at our pipeline again, we'll refresh the page here and we'll see, okay, so that kicked off a build right away. And so now we're building this application again, our Cool Stuff store, with this updated code, with our updated version of Commons Collections. So real quick, well, we're going to let this build, but I wanted to sort of come away with 3 takeaways here. So first, in the way that technology is changing and the speed at which engineering organizations are moving, you have to be hyper vigilant about your supply chain. Your developers are going to want to, they're constantly changing their code base, they're constantly pushing new software, and there's constantly new tools that they want to use. And so all of this stuff is being included in your applications, and you need to be aware of what these things are. And you've seen in this demo today how, just one day your application can become vulnerable because suddenly a component that you're using, a vulnerability is identified. And so you need to be hyper vigilant about this. Second, you need the right tools for the job. So in the modern day, with all of these components and how complex our code is becoming, it's too hard to do this manually. I mean, there's a lot of smart people out there. You guys are all smart people, but you just can't do this manually. And luckily, there are tools out there that can make our lives a lot easier. And so we need to use these tools. And lastly, and this is a really important point, application development still comes down to people. It's still people who are writing the code and pushing that code every single day. And so the tool and the framework that you use in your organization, the best tool is the one that allows your developers, your people in your organization to work most effectively and efficiently. So now we're seeing here that our build was successful. All green, we fixed our vulnerability. So Justin, stay out of my application.
So I just want to add a couple more points to this before I move on to the rest of the deck. So first off, this CICD pipeline is pretty simple, and we didn't really talk much about the later on steps. So I'm going to do that now and additionally recommend some more things that you might want to do. So we spoke a lot about the build and security scan. What we really didn't talk too much about was the CD portion of this, the continuous deployment. So first there you see after the security scan we deploy to some dev region that should be again production-like, and in this case it's pushing a new container, or in OpenShift's case a pod. It's bringing up a pod with the new version of our application. And then the second step there is acceptance testing. Acceptance testing is basically running against your newly deployed application and treating it as a black box. So it's treating that and testing that as it would be deployed in production. And that's kind of something that's incredibly important. What happens if when we upgraded 3.2.2 of Commons Collections, what if the functionality changed a little bit? It's not supposed to because it's a minor release, but let's be real here, that's not always true. So what if it broke something? We want to know if it broke something that relates to our application. So we need that acceptance testing stage, black box testing, to feel comfortable deploying stuff to production without any kind of manual effort. And a lot of times there's, you're just doing that automated dev deploy, and there's still some kind of manual user acceptance testing or QA testing, but this step limits that and is incredibly important. And then also there's other steps that we didn't add in here. I personally would recommend running performance tests after every build. What happens if Commons Collections changed something that they did that took twice as long? So now your application, instead of being able to handle 1,000 requests a minute, handles 200, and you need to either fix it or deploy more servers. There's lots of different ways you can handle that, but you need that information. So again, these are just 4 basic steps, but there's plenty more that you need, and do whatever best fits your organization. Sorry about that, I jumped a slide. So supply chain best practices. First bullet there is fewer, better sources of components and higher quality software. What I mean by those 2 points is that you don't want to use 10 different logging frameworks in your Java applications. You want to use 1 or 2. You don't want to have to maintain software that's using so many different versions of the same thing either. You don't want to use 50 different versions of Commons Collections, because then you're going to have to upgrade your applications in 50 different ways. What you want to do is pick a few different things, hopefully limit that to 1, 2, 3 for every single piece of functionality you need, so that when you do have an issue, you can fix it as easily as possible. And also touch on the higher quality software part. You you can pick fewer pieces of, fewer logging frameworks, but if they're not high quality, if they're not maintained, what if a vulnerability is discovered and it takes them a year to fix? What are you going to do in that year? Are you going to rewrite your application's entire logging framework? That might take a lot of effort. So the goal here is we want to recommend you pick software from places that you trust them to fix as quickly as possible. No one's writing perfect software. It just doesn't exist out there. There are vulnerabilities being discovered every day. Some of them are major and some of them might impact your application. What you guys want to do is pick software from the places that will fix the issues as quickly as possible and hopefully limit their existence at all. And then the third point here is keep track of all your components in your applications. That's kind of back to that bill of materials step that Nick mentioned in the demo. We want to know what components are used where so that when we do have issues, we know where we have to fix them.
Okay, so what's next? If you already have continuous integration and continuous deployment with a full iterative build process, to make this security vulnerability testing process seamless, you can talk to us about adding in Red Hat OpenShift to deploy your applications with a security-first mindset. What if you're only using some of the tools that have CICD capabilities, and you aren't using these to promote to your environments or run full integrated test suites? You can start by downloading Red Hat OpenShift, starting to integrate this tool within your current CICD tooling, and start running test builds and deploys to see how you can use this to speed your time to market. Just as a takeaway, no matter where you are in your CI/CD pipeline development, we want to get across how important security testing along with integration testing is in your environment to remediate security vulnerabilities as quickly as possible. CI/CD goes hand in hand with unit and integration tests, but we want to change this mindset to ensure security is thought of just as equally. So the next steps with security fundamentals. So what is everything we're talking about? How does it relate back to industry standards, industry fundamentals for security? According to the cybersecurity framework, the proper way to go about ensuring your environment is secure is this diagram. So, as you can see in that diagram, it is in a circular fashion, just like Agile. And you want to identify easily. So are assets and configurations well known? Do you have that bill of materials that Justin and Nick spoke about? And in terms of protection, can you prevent unauthorized changes and access? Do your teams have the necessary skills and tools to protect your environment? How do you actually detect when a security vulnerability comes into your environment or someone tries to exploit it? And how do you respond? Do you actually have controls in place to mitigate against an incident? And are the tools in place to analyze an incident and recover? How do you get back to normal? How do you go from that response step to recover? And what does that look like? What process does that look like? And these security fundamentals really cover every piece of your environment, from infrastructure all the way up to application development.
So Emily spoke about the security fundamentals framework, and she spoke about it in a kind of generic sense. We didn't talk about how this framework can relate to the CI/CD pipeline that we showed you. What she spoke about was great and incredibly important, but that might be what you're doing today. You could follow these 5 steps after the fact. Again, what we're trying to promote is push left, push as forward as possible, as upfront as possible, so this happens as soon as possible. So let's talk about what the identify step here means. And again, create a CI/CD pipeline that inventories all software. What do we mean by this? This is just creating that bill of materials. Protect. Include tools in that pipeline that warn and notify you of anything that's against those policies. Detect. Again, the protect and detect kind of overlap here a little bit. But now that you have those tools in place, notify you when something is wrong. And we've spoken a lot about this in terms of a build, right? Said you push your code, you know that there's a vulnerability there, so you fix it. What we hadn't spoken about yet, which I just want to cover briefly, is what happens when this isn't tied to a build. Commons Collections 3.2.1, for example, right? That was in production in, probably thousands of applications out there, probably more. Even if you have that step in your build pipeline, if you're not actively working on that code, you might not know, even if your build shows as orange. So just as an important step in that detect pipeline is monitoring that bill of materials continuously for things even already deployed to production. And the Sonatype tool handles that, and other tools do handle that. They're not just going to notify you when something breaks in a build. They'll notify you if anything in that bill of materials later has a discovered vulnerability that happens after the fact. Respond. Knowing all that information you know, what are you going to do to fix the vulnerable component? And let's look at that in terms of Commons Collections again. What did we do? We upgraded to version 3.2.2. Another equally okay option is confirming that your application doesn't do untrusted serialization. Or if it does, fix it so it doesn't. I would recommend always using the latest version of components so that just in case you did something wrong and you messed up looking at your code, you're hopefully safer. But if it's faster to get to production to fix your vulnerability by just not allowing untrusted deserialization, that's okay too, and you can upgrade your component in your next release. And then recover. What do we have? After we respond and identify what we need to do to fix it? This is the actual fixing stage, running all our tests, and then finally getting it promoted.
So I'm just going to leave you with a couple last thoughts. As we are consultants, I do want to talk a bit about Red Hat Consulting, and I want to let you guys know that Red Hat Consulting can help you in a mentorship model no matter where you are on your digital transformation journey, from the basic steps of exploring to being in a fully Mode 2, in the words of Gartner, infrastructure. This approach can help your business be more secure while increasing innovation and value to your business. Lean on Red Hat to help you with your digital transformation. We have improved the lives and time to market for tens of thousands of customers. Let us help you do the same. So we're going to open it up to questions now. We just wanted to leave this quote that we all find it as a favorite by Gene Kim. So we will start reading from the question stream now.
Okay, so we're going to start answering some of your guys' questions now. So the first one I want to answer is, what does CVE stand for? We probably should have covered that in the presentation. Sorry about that. For those of you that don't know, it stands for Common Vulnerabilities and Exposures. And the second part of that question was, who builds it? And it's built by a lot of people. There's a lot of researchers out there that try to find vulnerabilities. And then also, if any vendors or people that built the projects found them, they can create a CVE. The next question I want to answer is, why use Jenkins here instead of the native OpenShift CICD capabilities? And there's a bunch of reasons for that. A lot of these third-party vendors, such as OpenShift or Black Duck, creates Jenkins plugins so that you can use their scanning software with Jenkins. You don't have to, but so you can, so you can see it in your build. And also, we provide plugins that can run in Jenkins to help you do deployments within a Jenkins pipeline. What's next? Could you use the white, gray, black list of artifacts to eliminate the potential for any developer using any vulnerable components in their application? So yes, you can, but that's tools built into more of a repository manager type product, which is not covered by what we're talking about scanning. We were just talking about scanning your applications and your containers so you can see what vulnerabilities are there and remediate them. The next question I have is the security scan software part of OpenShift? Is it only included as a Jenkins task, or does it work natively with the OpenShift 3 native CICD built in? So it's not part of OpenShift by default, but again, if you want to work with any of the different products we mentioned, it's fairly easy to containerize them so that you can actually deploy them in a container. And I'm not really sure about the answer to this question, but hopefully soon, if not already, some of these third-party vendors will start providing a Docker file or an image to actually deploy these in OpenShift so you don't have to do it yourself. They might already. I'm not really sure to the answer of that question. So the next question I wanted to answer was, does it also check compatibility of different components to build an application before suggesting versions that are not vulnerable? And as far as I know, the answer to that is no, it does not. But that's also why the build aspect of your pipeline and any kind of acceptance tests are incredibly important, because it will tell you that the components are no longer vulnerable, but you don't know that your applications work after doing the upgrade. So that's why it's incredibly important to build and automate a good testing framework so you can be confident that when you do make changes, your applications still work. The next question I have is as far as these, using a tool like Sonatype Lifecycle, doesn't repository managers also tell you this information? And the answer to that is some of them do. But they don't tell it to you at the application level. You can look in the repository manager and see, oh, this component has a CVE, but there's no means of like notifying you, oh, your application A uses that, and that has a vulnerability, so we want to fail the build and provide a warning or let you know after your application's in production that there is a vulnerability. Let's see, let's look at some more of these questions. So are there tools within Jenkins or OpenShift who could also run tests against compiled binaries as far as that's possible, or can we only check sources? So there's a couple different ways I can take that question. So the Sonatype tool does scan the actual binaries. If it's a Java application, it will scan your WAR file, and it will scan the actual binaries to identify those components. It's not looking at like your POM if you're doing a Java application to say, oh, this has version 2.3.2 in it, something. It's actually looking at the binary to identify the version. If you're talking about other kind of scans like static code analysis against either your code or dynamic code analysis against your binaries, I'm sure there are tools that you can build into OpenShift to do that kind of stuff. Unfortunately, I'm not aware of any off the top of my head. Sorry, guys, I'm going through the list. Okay, so I'm surprised that you guys are advocating black box testing after deployment rather than right after the build occurs before deployment. So that's a good question. And again, I'm kind of talking about in a development environment there. So if you want your code in your development environment to be more stable, doing that in like a pre-dev environment is entirely okay too. You can do your build, deploy a pod that has your application in it that's not your dev environment and run your black box against that. The only point I meant there was that you should be deployed in a production-like environment when you're doing your black box testing. Not necessarily, doesn't have to be your dev region. Just deployed somewhere is what I meant. What else? Is there a way to to actively scan running applications, and sorry, the question list is changing as I read it, so I just lost where that was.
I got it. The question is there a way to actively scan running applications to identify code that may be actively exploited?
Okay, so the answer to that is I don't think you can scan a running container, though you might. There are tools coming out every single day that are more focused around container scanning and Docker than just around like Java applications or middleware. But in terms of running applications, these tools that we mentioned are not only tied into your build, they will notify you as when an application is in production if one of the components in that bill of materials it generated does have a vulnerability. So it's not only going to fail your build or show up as orange in your build, it will tell you after the build happens. It will tell you later if a new vulnerability is discovered.
So another question is, which team should be in charge of the security policy in terms of deciding if critical, severe, or moderate should be fixed or upgraded?
Okay, so and again, that depends on your organization and how you guys do stuff. We're moving towards, DevOps, or rugged DevOps is another term. And my answer to that question would be that these teams should start working more closely together. You should define policies with your applications teams for what makes sense to them. But obviously, any single organization is going to have security policies in place. So they can be, it can be done at multiple levels. Another question is, how does Sonatype Lifecycle compare to Fortify in terms of dynamic vulnerability check? There are different tools. So again, Sonatype's tool and any of these vulnerability tools that we mentioned earlier are not doing dynamic vulnerability checks, or not looking at your source code to say that, oh, I messed up how I did my authentication here, or this is a common mistake. It's checking based on a bill of materials. So it's identifying the components in your software, not necessarily how you use those components. So for example, with commons collections, it's not going to tell you, oh, you didn't do deserialized, untrusted serialization, so it's not a big deal. It's just going to say, here's this vulnerability that's associated with this library, and then you can go on and check your application if it's exploitable with that given information.
Okay, and there's a question here. Can you give examples of companies who have adopted the CICD approach? So I don't know which ones are public or private off the top of my head, but we will be sending out a follow-up email. So I will include the public case studies that have used OpenShift or general JBoss middleware technologies who have adopted that CICD framework, along with potentially test-driven development and behavior-driven development. So that we'll send that out after.
Okay, I think that's all the questions that we have right now. So thank you, everybody, for joining.
Yes, thank you.
Thanks.